Sir, welcome, sir.
Thank you.
Yashwant, sir, is an AWS certified, having over 8 years of IT experience and a sabbatical year as an elected student representative. Sir is associated with front-end technologies, cloud, and big data. Sir worked with Amazon, Telefonica, MMT Digital, bid on this, and currently with Vodafone UK. And today, sir is directly connecting to our session from UK. He's a former editor in chief for our college newsletter Voice of Vagdevi, former vice president at University of Staffordshire, former member of National Union of Students UK Block 15. Sir previously worked in Amazon. He implements sleek serverless architecture with BidThis e-commerce company in UK. Sir achieved zero downtime deployments working with MMT Digital UK, worked in setting up cloud environments from scratch, and worked migrating cloud projects in telecommunications and e-commerce industries. And today, sir is going to tell us how to deploy Python in cloud. Sir, welcome you for the session and over to you, sir.
Thank you, ma'am. It was a very warm introduction about me. Uh, Let me share my screen and please let me know if you can see my screen. Yeah, hope you all can see my screen. Can you all see my screen, madam?
Yes, sir. Yes, sir.
Yeah, thank you. It was a great session by Dr. G. Narasimha Garu about Python session. So now we would be going into looking at how do we deploy Python into cloud? How are we deploying Python into Amazon Web Services? So before starting our session, I want to just give you just about why Python and why Amazon Web Services very shortly, and then we would go into various deployment techniques and deployment methodologies and architectures which we follow in the real world. So Python has been very popular since last decades. It's a 30-year-old language, but it has gained very popular with cloud computing. The major reasons are its web and internet development. So a lot of web apps, web application websites are built using Python. In Python, we have something called Django framework and pyramid frameworks, which gives us very ease in developing the websites, and micro frameworks like Flask, which helps us to run functions such as Lambda functions in cloud computing, which I would take in later sessions. And even for the website to publish content, we have Plone and Django CMS, which is very popular to publish the content. We just push the content like changing the images, changing uh, the thumbnails on your website without changing much in code or without any change in code. With advanced content management system, you can just push an image so that without touching the code or the major code in the production, you can deploy a new image onto the website. And for system administrators, uh, you know, it's a big doubt. How do you access AWS services with Python? But if you're a system administrator and you want to run everything, like to turn on your servers, to update your servers, or to down your servers, or to maintain your servers, or anything, or to do extract logs from your servers to a destination, or to copy them to a destination and save them, you use Python as a code. So you can use Python for that. And for testing your front-end application or a web application, you can use Python. So a thumb rule is that if you develop a website or a web application with Python, then you also test it with Python. So in DevOps, as I said, in configuring all your tasks and setting up your cloud, setting up your servers, the required instance, the instance types, I assume that you might be aware of, what are the different instance type, like T2 micro, T2 large, like what is the size of instance you want, how many number of CPUs you want from AWS, and all such expectations can be written as Python as code. In real time, we normally don't do set up our instances with the GUI provided by AWS. We always recommend to go with a pipeline as code or infrastructure as code written in Python or any other comfortable language which the user is friendly with. And Python can also be used in scientific and numeric big data and a lot of business applications like CRMs and all. So not going into much depth around this part, I would continue to get onto Python for cloud computing. So one of the major reason we get into Python is is very interpreted language. So you just don't need to compile. So if you want to run Python in AWS, you can just write a single line of code and just run it, like, turn on the system, like, to get set up an instance, to run an instance, to configure an instance and change the memory settings or CPU settings or anything like that, or to scale up, scale down. In Python, it is very comfortable as it is very interpreted language, and it is a scripting language. So it's not an object-oriented program. So here I've compared the examples, like. Uh, in Java, you need to define class and all. You have to use a lot of parentheses, a lot of characters have to be involved. So your length of code also increases. So when you are thinking about cloud, keeping it short, because you would be paid for the resources, would be very advised. So that is the reason Python is dynamically typed and executed. It helps you know us to run the code very easily on the cloud computing level. So if you are running cloud, as you might all know, we pay for what we use. So the amount of lines and the number of code memory you pay for it. So the simpler and easier the code is, the better to run and save your resources. So basically, Python, deploying Python into has been changed in over years. Over years, to understand how do we deploy, we need to understand how the architecture works. How do we deploy the Python? Basically, migrating from on like on-premise data centers or on-premise organization. Suppose an organization stores all its data in on-premise, and if it want to migrate to cloud, basically there are, like, three broad varieties of projects which normally do. One is lift and shift projects, which, like, where we shift our code from the existing on-premise data center or on-premise organization center to a cloud resource like AWS or Amazon Web Services or Azure, Microsoft Azure, or GCP, Google Cloud. So we lift and shift all our architecture, all our code directly into cloud. Okay. And the second way is, because we are moving into cloud, we also have something called microservices architecture and getting completely serverless with cloud. So as I told you just about lift and shift methods in monolithic architectures, what we normally do is we pack our code into a jar or var file and just executable or an executable file and deploy it as a single file, where all your web application, all your websites, suppose take any application like Amazon e-commerce sites like Amazon.com, uh, eBay.com, or Flipkart, or any other websites, you pack the complete jar file into a single file, keep it on your server, and execute it. So in the old world, before cloud computing, people used to run this code on their local data centers. Hello, can you hear me?
Yes, sir. Yes, we can hear you, sir.
Sure. Yeah, just let me know in case if I'm dropping, or if you have any doubts, so that I can clear the doubts then and there.
Sure,
Yeah,
sir.
yeah. So in monolithic architectures, what we used to do is, suppose you have a in-house data center or in-house servers. So we used to have, like, 100 servers for our web servers, 100 servers for our business logic execution, 100 DB servers like that, and where we used to pack our code and deploy the code into all those servers. And that is how we used to do in the monolithic architecture. The entire code is packed into a single application, uh, and the data is mixed from different business constraints. Suppose on a website, if you go to Amazon.com, you see, suppose you want to buy latest Apple phone. So you would search for Apple phone from different sellers, or different Apple phones. You would look into different models and all that. So that data about device, or the data about the product, or the product which you want to buy, is shown from the business data model from the product side, and then you select the model, then you basket it. So you add to your iPhone, you add the cover, uh, screen guard, and all this. So other basket details, like adding all the value is done from the basket uh, DB. So we are mixing data from different sources and displaying it to the customer. And it has mixed business logic because you work on different backends. Suppose when you look into Amazon website and you want to order a product, it gives like fast selling, last 5 products available. This data is shown from data warehousing. Again, the details about product is given from different, like the product details are given from a different business logic. So like when you select a product, the number of products available in the basket is shown from a different unit, and the product details are shown from a different business logic unit. But uh, the overall experience to customer is given as single monolithic architecture, and uh, you are deploying your code as a jar file. But when we move into cloud, what happens is, uh, suppose if you are on a monolithic architecture, you run your entire service, you run entire thing. Suppose uh, on a big launch day or a big Friday or something like that, big basket day, where Flipkart or Amazon.com goes on a sailing bash, a lot of people, like, 1 million people would log onto their website, just browse the items, and only thousands of people would basket them, and only hundreds of people would do a checkout. Which means that you are keeping all your resources. So you are packing the single code as a resources and deploying it to hundreds of servers, and all the 100 servers are running. So the traffic, the number of services and servers you are running for your browse journey and for your basket and checkout are the same. But whereas on browse you have millions of customers, in checkout you have thousands, and sorry, in your basket you have only thousands, and people who really order are only in few hundreds. So you are wasting a lot of computing power. And when you are deploying your code into cloud computing, so whenever you get into cloud, you pay for whatever you use. So if you keep a monolithical architecture in cloud, you still pay for whatever you don't use. So to solve this and to get the better experience, and to pay for what we are using, we have migrated to microservice architectures. So when you are migrating for or deploying your code, your Python code or any code, the best first part is migrate your existing code to cloud like AWS. So it gives you the confidence that okay, my code is not changed, the only infrastructure, underlying infrastructure is changed. So you can troubleshoot, you can get it fixed very easily, and from monolithic start migrating to microservices architecture. What is microservices architecture? As I just explained you, that on a sale day, like Flipkart, on a Friday or a big Friday sale day, a lot of people browse the content, few people basket, and only very little people do checkout. So here what are we doing? So thousands of people are opening the website. So you want to architecture the browse journey where people, the browsing pattern as a journey, and basket as one journey, and people were are adding different basket items, like people are adding phone from from one vendor, adding a screen guard from another vendor. So you are basketing from different things, and in the basket you add up, do the summation of all the prices, you add a voucher if the customer has a voucher, subtract the voucher amount, and make a final amount of how much the customer has to pay. So you are using a basket service where all the basket operations happen, and in the next page you have checkout. So in a microservice architecture, all your browse journey is put in one basket, in one journey. In your basket operations or basket journey, all your basket code is put into one journey, and all your checkout is put into a one box, or one box where you do checkout, when you do your bank payment, where you select your shipping method, what should it be, fast, slow, or postal delivery or something like that, and then you do checkout, you pay your bank card details. So this is another journey where in this you transact with your bank, you get a a transact pane where you have to enter your card number. So all this is packed into one single pack. So now what happens now, as we are in cloud computing, we do scale up whatever you want to scale. Like, on a big Friday day, you keep 1,000 servers or 100 servers for browse and 50 servers for basket and only 10 service for checkout. So you have paying whatever you are using. So that is the reason in cloud we started migrating to microservice architecture, where application, take any e-commerce, telecommunications, or any other big websites, so these can be microserviced and deployed. So business logic and data will be bound to the business context. Like suppose you have the basket journey. In basket journey, what you have to do is add multiple items in basket, where you can add rules like a customer can't buy more than 2 phones. So you add that kind of business logic into the basket context, where people can add baskets and add only vouchers, and you can add a logic like, one customer can't add more than two vouchers. All this kind of business logic would be pertain to that single service only. Like, you can say to that service single container only, and the operations are done. So by migrating to microservices, we ensure that, unwanted infrastructure is not used, only required infrastructure is to used. And suppose if there is an error in basket, your voucher, you can't add vouchers, none of the customers can add the vouchers, but still your website runs and people can still browse the journeys. Only the basket adding voucher functionality would fail. So making the business loss minimal. Whereas in monolithic architecture, if people there is an issue with errors, there are high chances that your entire website can go down. So that is the reason why we have microservice architecture. And another advanced architecture is having serverless architecture, where application consists of multiple functions. So in here, in microservices architecture, you bound a journey to a microservice and run them in a container. But in serverless architecture, you keep your code directly into Amazon, which I would cover next. So you keep your Python code directly into Amazon as a Lambda, and you just run it serverless. So you don't know which server it is running. Never mind how many servers it is running, or you just give the code to services like Amazon, and they run the code for you. And they are highly scalable, because you don't have any limits. You have only limits like, how many minutes the code has to run, and how much memory your code should be allocated. But the number of instances and the servers it's running is completely in the back end. And application consists of multiple functions. So you can again add multiple functions into your code, but you can't add but you can have only one expression. And here you have fine granular steps, like, if you want to get the details, like, get the basket items you have placed. So only to get the details, or to for basket operation, you will granular it to get basket, add voucher. So you program everything into single granular unit and deploy into serverless architecture, so that everything is granulated, everything is added. So literally every API call or every call which you make on Python calls or anything you make is granulated to a single unit and run, so that if something is down or single call is down, it doesn't impact any of other calls, and making it more serverless and making you more cloud. So as I said earlier, we used to use a monolithic architecture, where we used to have mobile, e-commerce, catalog, and everything. So you used to have data warehouse, where you have all the data. Like suppose a e-commerce website having all its product details would be displayed in mobile, e-commerce, and catalog, completely from single source of data source. And all the front-end applications like their mobile app, e-commerce website would render the data from the data warehouse on the real-time basis. And suppose if data warehouse or some issues occurred in this data warehouse, all your application might have go down, and all your transactions get down in monolithic architecture. And moreover, you in data warehouses and all those backend layers, if you are running on-premise data centers or on-premise servers, you buy the servers and run. Suppose, on a big day, you run 12 servers and you manually turn off uh, your servers on a normal day. So you have to manually keep on checking, like, how many servers. So you have to do a lot of investment and keep your servers ready. And again, a lot of prep has to be done in maintaining those servers. So suppose if you are transferring your code or your Python code from on-premise to directly to cloud, then you can use Amazon EC2 services, where EC2 is nothing but your Elastic Cloud Compute or Compute Cloud. So where you run your code directly. So it's a server given on by AWS rather than home. You can just run your code. All you need to do is lift and shift your Python code and run it as a whole on the EC2. But as I said, this method is not really great for cloud computing because you have to increase the number of instances, run the whole cloud on EC2, and it's running as a plane. But the best way to deploy Python code is always getting into microservices architecture. Let me get into how do we deploy. Suppose in monolithic architecture, as I said, you have your user interface, all your business logic is done in single pack, all the user interfaces in the single pack, and you access data. Suppose, uh, as I said, to get the product details, your business logic is in the same layer. To add and check the contents of basket, your business is still in the same layer. And to check OCHA or OCHA validity, everything is in the business logic, the same pack of code. But in microservices, what we have is we have different packs of code where in one pack you keep all your browse data, you keep all your product details, in one pack you keep all your pricing details, in one basket you keep all your basket details where you can add logic such as a number of items can be bought by a single customer, adding a voucher, subtracting a voucher from the whole amount the customer has placed, then checkout. So you can have a number of microservices where you can keep on adding and checking the logic. So suppose if you add, uh, as I said, and you can also have individual DBs, like in product microservice, you have a product DB where this microservice gets all its product details from its DB, and it would have access to product details only. In this way, you can restrict your DB access to only pertinent users who need product data. So in this basket, you have only product information like an Apple phone, or is the model, what is the SKU ID assigned for it, like stock keeping unit assigned for it, and you have a Samsung phone, and what is the stock keeping unit assigned for it. So you have all these details, only the product details in this DB. In this DB, you can have details like basket, like what is the amount, or what any internal operation, any basket ID reading operations, like what are the baskets which customers have saved, and which the customers come onto the website, save their basket and leave it, and come on 10 days later and buy them. So all such kind of information which basket has created can be stored in the basket DB. And when checkout information can be saved in the checkout DB, so that if something is down, suppose basket DB is down, but still you can process all this information. But whereas in monolithic architecture, you completely depend on one single architecture. So this microservices are now deployed into cloud. So how do we deploy this code? So before going to how do we deploy, I want to tell you the advantages of microservices. So in microservices, software is built as microservices can be broken into multiple component services, as I said you before, and each of these can be deployed individually. Suppose on a big batch day, you only deploy new products, but you would not change any code, so that you can just do a change of this service here and deploy new product microservice, so that nothing is changed and the change is easy, quick, and you can get the confidence that even if something goes wrong, the new product launch can be stopped, but nothing to other microservices would be solved. So whereas in this monolithic architecture, you have to deploy the entire code into single var file and deploy it, making it more riskier and more troublesome. So, but in monolithic architecture, you can deploy whatever you need without touching which thing which you are not deploying. So you can just remove it. And in troubleshooting also, if you are in a microservices based architecture, it would be a better fault isolation. And if one microservice fails, you don't need to continue working on troubleshooting the other paths. So you can fault out, you can silo whatever is the problem and just troubleshoot your silo and get it resolved. And as I said, Python is easy to run, but we should not get stuck with all the deployment process and all that. So it's easy to integrate and deployment is easy. Uh, and for deploying, you can use a lot of open source tools like Jenkins, VSTS, Azure DevOps, and GCP. And in AWS, you have code pipeline and code commit and code deploy. You can use all these tools to deploy your code very fast and quick. Uh, and by using microservices architecture, it enables continuous delivery. Early days, when I was starting my career in IT, we used to have this monolithic architecture deployments where, we used to jar the complete business logic file and give it to support team, and they have to install it, deploy it, check everything is fine, the connectivity is set up, and everything is done. But nowadays, we literally do multiple deployments every day. So whatever is the change, whatever, suppose you want to add some business logic in basket, increasing the number of contents customers can buy. So you just deploy the basket logic here into production. So microservice architecture enables you for continuous delivery of the new services into the production. And the other thing is microservices are very scalable. As I told you earlier, suppose on a big basket day, your browse journeys have to scale a maximum. Suppose you are running on one server on a big bash sale day, your browse journey has to scale 1,000 times, which is needed. But your checkout can only be scaled up to 10 times, not need to scale up 1,000 times, because all the customer who browse your website doesn't mean they buy it. So scalability and reusability and efficiency as well uh, helps you to achieve with microservices. And other major thing with because you are running in cloud computing like AWS, it is spread across multiple regions and multiple uh, edge locations, multiple locations, and multiple data centers. You can make one container running in EU Ireland, one container in Dublin, uh, one container in London, and one container in Paris, and the other container in Mumbai, so that you maintain that availability, high availability across the regions. So in case if there is a disaster in Dublin, your Dublin container would affect, but still your website would be running, your application would be running from the other containers in London, Mumbai, etc. So again, if you write your Python code into container format, you can run this containers. You can do this, write this service in services called Docker or Kubernetes, and then deploy it very easily. So what you package your code into a container like Docker and deploy it directly onto AWS, so making it very easy. And microservices simplify security monitoring because, uh, as I told you earlier, uh, suppose you keep your product DB here, and the team which needs to deal with product would only have access to product DB, and they would never have access to the customer data, where which customer is buying, what is the customer's credentials, or any other such data. So you can secure your data, whereas in monolithic architecture you have a single DB and every team has access to the same DB. But in microservice, you can restrict DB level access so that more data can be secured. Any doubts? Because I want to go into like other parts of the session. So can you let me? Can I? If anyone has doubts, you can ask me. Okay, I would continue to the next part. So Docker, as I said to you, Python, one of the major difference, as I showed to you in the previous slide, you know, uh, Python is simple and easily scriptable and dynamically written language, it makes you very easy to interact with a lot of other components, like to other systems, other services, and easily packed code, and you don't need to compile. It is just interpreted. All you need to do is just type your code and it gets interpreted. So it makes it easy. So as I said, we keep all our microservices, we silo our code based on our journeys. What we do is we pack all this code into a container, and this container which we use is, we can use Docker, Kubernetes. These are the top containers which are currently available in the market. You can use ECS, Elastic Container Services from Docker, or EKS, Elastic Kubernetes Services. Kubernetes is a Google product. So if you're using GCP, it is 10 more to use Kubernetes, but Amazon is equally tended or equidistributed between ECS and EKS. So what is a container? Containers are lightweight, standalone, no environment hassle, and choice of applications. Uh, basically, you can containerize your Python, your Java, Node.js, or Angular, React Native, any or Golang, which is becoming very popular these days. So any code can be packed into containers, and get this logic. So in container, you pack something. So suppose if you want to deploy something to production without downtime, what you do is you package your code and deploy it into production and keep it as first version. So if you want to deploy with downtime, what it is very easy to write another version of your code as version 2 and prepare a box or prepare a container and just replace the container which is running in production. So change your container from 1 to 2. So if you replace that box or that container, it's very easy to deploy your code in no downtime. So containers are very lightweight. They're standalone. You can make your code silo and deploy it, and you don't have any environment hassle. You can deploy one container in lower environment or a dev environment where you're running your code. Like in the previous session, like Narasimha sir has told, you can run your local host code, make sure that code is perfect, and then you can just pack it into a container and then deploy the same container into production, so that you can deploy the same container in all the environments, making it very easy, and you don't have any other environment hassle. And in containers, you have choice of application. Docker and EKS is growing day by day. So you can just get a Docker container with Python installed it, Python 2.7 or Python 3.8, install it from the internet, and you can just write your Python code, compile it, and deploy it. That's it. So you are ready to send your code directly into production within minutes. So earlier we used to have get a server, install Python on it, install all the packages which you want, and then deploy and then jar it, build a new production environment, and get an instance or get a server, install Python in it, and keep that jar and run it. But now you can pull a Python code from Docker very easily, and within minutes you can write code and deploy it into production, which makes it very easier. So what is Docker? As I told you earlier, we used to have our infrastructure where we used to have hypervisors, and we used to install operating systems pins, and then on top of that your application runs. So earlier we used to get our cloud, like our server, or in AWS EC2 also you get a AWS EC2. You define how much CPU you want, how much memory you want, which is the instance type you want, like T2 micro, T2 macro, and all that. And you install the operating system in it, like Windows operating system, Linux operating system, or Amazon Linux, Kali Linux. You can install anything, and you have to install your Python in it, and then write your application and then run it. But now you don't need to take anything, like host infrastructure, you get it from AWS, and you get a Docker container. In the Docker container you can directly get a pre-installed Python version 3.8 or 2.7 from internet, and then directly write your application onto the container and deploy the container, which makes it very easy. So for containers, to ensure that they are seamless with environment. Earlier we used to see this very often, that developers used to tell that it works in his machine doesn't work in my machine. It works in lower environment, but it doesn't work in production. But now you can't say that, because your code is completely packaged in Docker. All you do is shift your Docker from one machine to other machine, from one server to the other server. And the other thing, as I told you, in the in the microservices architecture, each runs separately on separate set of devices. So suppose you want to give a very advanced texture for your uh, mobile application users. So you can run your front end in React Native, one container with React Native, and the second container with Python, where all your business logic is written. So you can have two different containers deployed, and code runs in different way. Like I told you, you know in the use of interface, you can have container with any user interface friendly like Django framework, Python. And in microservices, you can have NumPy or any other Python sources, different version or different variables, and you can just run the code, making it very easy. So making it very easy and silo. And applications are independent of each other. As I told you earlier, suppose if one container dies, you can pull the other container from your registry very easily and spin up a container within seconds and minutes. So the application is independent of the other I mean, micro level in micro level, it is independent of other things. And systems can be scaled easily, and code can be deployed effortlessly. As I told you, if you deploy Docker, then as I told, your browse journey can you can only scale all your containers which are in browse mode, and you don't need to scale up your checkout as much as you scale the browse. So you can scale unevenly, whereas in the previous monolithic architecture you have to scale it evenly. So that is the reason these days you don't see, websites are down, Amazon is down. In 2010 or 11, sorry, in 2011, when I was working with Amazon, we had around 40 minutes of downtime on a peak sale day. But no more, we have reduced these downtimes very drastically, and reduced the dependency of infrastructure with the Docker containers. So Amazon has their edge locations, data centers worldwide. So sta- uh, we tactically place our containers in different locations so that downtime can be resolved, and even any infrastructure issues or infrastructure downtime by natural disasters can be overcome easily. So in AWS, we have ECS and EKS. Let me show you AWS, where we have uh, Elastic Container Service, which is called ECS, where in ECS you can directly deploy your containers with task definitions, where you can write your Python code or YAML code here and build your own clusters and deploy your code there. And in Google, you have Kubernetes, where if you can have Kubernetes orchestrated code also, where you can deploy it. So if you are running your Docker container out of Amazon or an independent, you can still use Docker Swarm mode, where you can spin up more containers on your need, add up more containers and deploy more containers. So Amazon ECS, with Amazon, and it gives easily monitored solution. Suppose by rule in production, it is always recommended to have two or more containers for each thing in case of any down or any server dying. So with ECS, you can monitor all these and scale up your containers, scale up your services very easily with very little effort. I want to show you how. And again, in ECS, we have two services in Amazon AWS. One is called Fargate. Fargate is completely managed by AWS. So AWS manages complete infrastructure. All you need to do is write a Python code and tell it how many instances you want, how much memory you want, how much CPU you want, and just give it to AWS. And AWS follows those rules and scales up or manages your infrastructure. So in Fargate, you can ask, for all your services, for checkout, for your browse, for your basket, you can ask the service infrastructure, give your specifications, then they give your services on runtime. So you can scale up, you can scale down. You are running service beyond two instances. You can get, suppose you want to do a lot of logic in basket region, you have two CPU, but whereas in browse you just select the catalog, so you keep one CPU. All you do is write it with a Python code and then just deploy it into production. In ECS Fargate mode, Amazon controls your infrastructure, so scale up, scale down, everything is taken care by Amazon, and it's Amazon operated service. But if you want to keep it in your hand, you can get your EC2 instances and run it in the ECS mode, where you get, five ECS instances or six ECS instances, and you run your various Docker containers. So in this ECS mode, you get your instances to you from Amazon, and you get spot instances, or uh, spot instance, reserved instances. You can get whatever instance you want. Suppose you want to run your production, it's always recommended to have reserved instances, where you reserve some amount of instances for your account from AWS, and you can have spot instances where you can want to buy instances on spot from Amazon and run your containers on these instances. So running your Python code onto these instances makes it very, disaster recovery and achieve zero downtime deployment. So suppose if you want to increase your browse containers, you still have your EC2 instances with you and EC2 nodes. You can, make increase your service task for one more quantity on the available instances. So you, this way you can scale up your containers. So as I said, if you want to go completely serverless, the first step is, migrate with Amazon API Gateway to Amazon Elastic Load Balancer. And again, load balancers, we have different types of load balancers called Elastic Load Balancers, Network Load Balancer, and uh, Application Load Balancer. Suppose, so these are basically load balancer, balances your load. It drives your traffic. So you had classification of elastic load balancer. So whenever there is, suppose you can keep a threshold on an elastic load balancer. Suppose you have your CPU of your browse goes more than 80%, you can write a Python code with the logic that if your CPU goes more than 80%, increase one more container. So when there is more traffic on your browse journey, CPU of your instance automatically raises up. So when your CPU reaches 80%, then you would scale up for one more instance, one more container, so that whenever your CPU races for more than 80%, you keep on adding your instances. And whenever your CPU falls below 20%, you can reduce one CPU, sorry, one container. So, whenever your CPU falls below 20%, you can keep on removing your containers. So that's how you normally scale up with your load balancer. So you build your code. Then with Amazon API Gateway, you interact with different microservices and different containers and different Python. Your Python code is packed into a Docker container and then deployed into ECS. And through Amazon API Gateway, you can interact between these microservices and you can balance your load, as I told you. So in a network load balancer, you balance it like, you have your browse journey. So suppose you have like, the best example is if you select a business user would come into this basket, and a regular user would come to this basket. So based on the user reactions and user specificness, you want to divide your journey and customer viewability, then you can directly do it with application load balancers. So you have various varieties of load balancers available with Amazon, and with load balancer you can easily access uh, the load and achieve scalability of your Python code, and then containerize it and deploy it directly into AWS. So that's how you can pack your Python code into container and deploy it into Amazon Web Services. And the other best way, if you want to go completely serverless, what you need to do is use the same method but choose Amazon Lambda. As I said, in Amazon we have something called Lambda, where you can directly write a code. uh, but currently Amazon has small specifications. All you can do is just create a Lambda function saying my task or something, and Currently, Amazon gives you a wide variety of options where you can run your .NET code, Golang, Java, Python, and all such code very easily. And I can select, if I can select Python 3.6, yeah, I can create a function. So this is making you from scratch. I can use a blueprint available and from a app repository that is also available. So from so yeah, so I already got you know uh, a function code, a GUI interface where I can write my piece of code here directly, and I have to define the settings like what version I want, how much memory to be allocated. So on as I said, if you want to run your code as a lambda, the maximum amount of memory which you can get is like 3000 MB or 3 gig, and you can run your code for 15 minutes at max. So you can write your code directly and run, and you can enable which VPC. Suppose you want to get the details of orders placed in last 1 hour, so you open the VPC for the order database as I said in the different silo, and give this lambda a function. And you want to see how many customers have visited your website, you can directly write a code and open the VPC gate for the browse journey, browse database, and get the details and display. So normally, it's a good practice. Like, as I said, Lambda charges you per how much time you run, how much memory you have used. So running tasks which are repetitive or once in a day. Suppose you want to run a task for getting order report every 1 hour. You only run 24 times a day. So you don't need to take a EC2 instance or elastic container. You don't need to write a container and run it only like 12 times or 24 times or 1 or 2 times a day. So it's just like, you run it for a couple of seconds. A few hundreds of MB of data is used to write that code and get the report. So you don't need to do it again. You just get it like, morning and evening. And for doing such kind of activity, reporting or controlling, so suppose if you want to scale up, so if your tasks are more like, you are running more than 100 containers, you want to add 10 more EC2 instances. So these all you can write in Lambda, and you can trigger your Lambda with CloudWatch. Like, design, add a trigger. You can, in CloudWatch, you can trigger like, you can add your metrics here. Like, if the EC2 instances reaches this threshold, run my task, and this is the destination. So you can achieve all such things. So just a second. Yeah. So as Python, Python is interpreted language. It gives, you the most advantage in writing your function directly here and executing, and it is easy machine readable. So the same way you can do it for Java too. Yeah. So as Java, as I told you, in Java, what you need to do is you need to compile your code. So what compilation? You have to write your code. You can't do it as runtime. As I said, in Python, if you want to increase number of instances, here you can directly do it and check yourself, test your code, compile it. But in Java, you have to compile your code as a var file and then import this from either S3 bucket. You had to add a zip file or jar file here directly, and then compile and run it. But whereas in Python, you can directly interpret whatever code you have written. But suppose if we have a small limitation in Lambda in Amazon, the limitation is, suppose if your code exists 10 MB, you have to add it as a zip. You can't directly look here on the console. So as Java is not an interpreter language, you can't write and just do it. But whereas Python is an interpreter language and you don't need a compiler, so you can directly write it and test it. So this is one of the major advantages which gives uh, Python edge over other programming languages, and this is the reason why most of the developers and system architects use Python over Java. And next is serverless architecture. As I told you, uh, I was showing you Lambda. In this Lambda, you don't know which servers you own it, and you basically don't own any server from Amazon. You just keep your code in Amazon, and Amazon runs it to you whenever you need it, and then you just charge for how much time it has run and how much computational resources it is used. But whereas running on EC2, running your Java code on EC2 makes, like, even to run a single task, like get a report, orderly report for every 1 hour in my 24 hours day, you still need to own a EC2 instance. You need to own a setup, like, you have to install the operating system in it, install the package and application into it, and then run it. So even though you are using just 24 times a day, you run your instance completely. And one vague method you can do is launch your instance every time, but you have to write a lot of piece of code and launch every time, and a lot of resources are needed. But whereas in serverless, complete serverless like Lambda, as I shown you just now, you just write your code, and you can set actions, and you can trigger your actions with CloudWatch, and you can cron your job for every 1 hour, so that every 1 hour my task runs and I get the data. So I don't need to look about any underlying infrastructure and such. But whereas in EC2 and EC2 instances in server architecture, I have to take care of my servers. Every time the operating system gets upgraded, I have to upgrade my operating system on the EC2 instances, and I have all that things. But whereas in Lambda, it gives me a smooth and easily transfer and easily a transferable, very easy and transparent way to write my code, and I can transfer it to any other application I want. So that is the reason Python has a very good edge on writing onto Lambda, and moreover, it is very interpreted language. It uses less resources, and it is very fast to run it and compile it and debug it. So advantages of serverless architecture is virtual servers, they are always up and running. So in EC2 instances, as I said, even though you don't use the service, so you want to get an order report every hour, you still run your server for 24 hours, but you run your code only once every hour. So you are paying and using resources when they are not in use. And EC2 instances are charged per hour basis. Suppose you run only 10 minutes in that hour, but you still pay for that complete hour. Lambda, as I said, Lambda is completely serverless, and you just ship your portable code there and mention your runtime environment, the code just runs. And you know how much scale it has to do. Suppose your traffic, your browse journey is in Lambda. So Amazon AWS Lambda takes care of all the scaling options, how much it has to scale up. And you pay only for what you use. Like, you run the code. If the code runs only for 5 minutes, you pay only for 5 minutes. So, that's how you can get into this mode of deploying code. So by using Python, that gives that advantage of, running very smooth and getting the code very quickly and easily. So as I said, starting and stopping of EC2 instances and any such as, this is one example which I've shown. So suppose I can, give my Lambda, write a Python code, and stop and start my instances. Suppose, as I said, in the CloudWatch, I can keep on watching all my instances. So if the CPU utilization goes more than 80% or 90%, I can spin up one more EC2 instance, and I can make one instance to two instances. So Python is very much easy and comfortable for doing this job. I think you have already gone through session on IAM. You can, specify the roles when this can run, which instance it has to run, which zone it has to run. So with CloudWatch events, it's very simple, and you don't need any manual intervention in making that. So whenever the CPU goes up, whenever your memory, you can configure whatever you need on your Python code, deploy it into a Lambda, and trigger it with Amazon CloudWatch, and it follows it. So any doubts so far? Any doubts, madam? Thank you. Yeah, just a second.
Sir, please
Sorry.
carry on.
Yeah, sorry, just a second. Sorry, I was having some water. Yeah. So, this is how you achieve deployments like blue green deployments where you never keep your production down. You would having uh, a production on blue, and green would be your P-Live environment. You keep all your code into P-Live, test it thoroughly, and just with minimal changes, and just with a small minimal changes of writing your code in Python, as a system administrator, you can change your traffic from blue to green. That is changing your traffic from production to P Live, so that your new changes are visible to customers. So that you can. This is a method where you can deploy your code and achieve deployments throughout day, 24 by 7, 365 days without any downtime. And and the other technique we always use is like use containerized technique, where, as I told you, you keep your task version number 3 on your checkout journey, and you can still run your task one version code on your browse journey. So suppose you have a latest features or new features developed on your checkout microservice, what you can deploy task 4 at service C, and once the traffic start moving to task 4 on service C, you can start killing task 3. Even by that method, you can achieve zero downtime deployment, and you can do deployments very easily. So once it's tested at lower environment, you can just take it into production. So that is you get with Python microservices. You can achieve the same with Java microservices, but the scaling up, all writing all these policies is very much smooth and easy with Python. And AWS integrally, gives AWS SDK called Boto 3, and Boto 3 is very easy to learn. You need to learn Linux, adding all your Linux commands, like basic commands like ls-la and all small commands. With all your small commands, you make a shell script. To shell script, add Python Boto 3, it becomes a Lambda. So you can step by step easily get to the stage and deploy your code with Python Lambda, and all the infrastructure, underlying infrastructure activities, environment activities, all the tasks, all the automated tasks which you do manually can be done with Python very easily. So that is the reason Python is more friendly than most of the other top end languages. Suppose Java might be very good in business logic, writing business process logic, but to operate the infrastructure at cloud level, at Amazon level, Python is more advantageous because it is interpreted language, and it gives that flexibility to run. So yeah, and whenever you're migrating, you always need to think in this, like operational excellence. Earlier, when we were out of cloud, everyone used to have access to the servers. Like every team members used to log into the servers. Now what you can do is you can ship your logs very easily to S3 bucket or CloudWatch, and everyone in the organization can easily view the logs. So that operational excellence can be easily achieved. Whenever you are migrating your Python code from monolithic or on-premise to AWS cloud, always think on operational excellence. How can you achieve operational, so that you can build and design your code easily and deploy in a better way. And the most thing is security. So in when you're deploying your code in AWS, you can easily get security enabled. You know, security is a shared thing. So again, in monolithic or on-premise data centers, you have to give access to a lot of people. But whereas in AWS, you can control who want to view the database. You can silo them, you can group them, and give access to the data which only they need. And reliability, as I said, in when you deploy your code into Amazon, you can launch across the regions. Like AWS has multiple edge locations, multiple data centers. AWS literally has like data centers across the world, so you can run one service in India South and one container in America, US East one. So you can do that. So so that your reliability increase. But whereas in your on-premise data center, all your data is run from one service center, which reduces the reliability and performance efficiency. As I said, writing your code in Python gets that extra efficiency because it is very easy, simple, and interpreted language, increasing your efficiency. So in Lambdas, you can, it's a single declaration with no name, okay, and which have any number of arguments, but you have only one expression. So going complete serverless helps you perform better. And cost optimization, as I told you, if you start siloing your application at individual component level, then you can achieve scaling activities whatever you want. And one of the regular activity we do is called nightly builds. Okay, we do build the code in nightly, and in the night we reduce the number of instances drastically with our Python code, which is helping us to achieve more costs. So in the daytime, every day in morning at 7, we spin up more services for our production, and by night 12, we reduce the count, and it's an automated task job. So by migrating to cloud, we achieve it. And in the day, even if you want to run more services, we can, as I told, we can write a CloudWatch logic to increase your instances count, and Python Lambda triggers it immediately and easily, and you scale up within minutes. So that's how you achieve scaling policy in a very cost effective manner. So whenever you're thinking about cloud, you're designing your architecture or deploying your code, keep these 5 principles as your benchmark so that it makes you easy to design your application and deploy it into cloud. Okay, thank you. Do you have any doubts? Yeah, any doubts? Yeah, yep, thanks. Looks like this session is smooth. Yeah, please let me know if you have any doubts so that I can come up.
I request the participants if anybody would like to share your views with sir and ask any queries. Sir, I think all the participants are okay with the session. No queries are coming even in the chat window.
Sure, madam. Yep.
Okay. Fine. Okay. So sir has already shared these PPTs with me. So today by end of the day, I will share all those PPTs in the WhatsApp group. So Yashwant sir, thank you so much. Your session was quite knowledgeable to all our participants. They all know Python programming, but how to really deploy this Python into this Amazon platform. You have given a lot of information and you're even sharing your slides. Thank you so much, sir. Hope it will help all our participants to practice. Thank you, sir.
Thank you. Yeah.